In this study, I would like to introduce an interesting topic about the perception of the importance of a per hour parking fee against the spending threshold for parking discount in more driving visitors' mind. The authors are Zhuang Zhengyun, Zhang Shuqing, and Zhong Chenkun. I'm Zhenyun Zhuang Wen from National Kaohsiung University of Science and Technology. In transportation management, public parking pricing is a popular topic for parking studies, which usually involves the WTP concept, which is willingness to pay. This has become a key measure for study in the past decade. Now it's evident that high-priced public parking decreases the overall parking demand by depressing WTP. In contrast, private parking pricing studies received less attention to the author's knowledge. Among these works, in a study, the pricing problem relating to how a commercial market's private parking resources could be utilized was systematically studied for the first time. The parking pricing decision for a commercial market's private parking mainly concerns the determination of P, which is the regular per hour parking fee, and the determination of S, which is the minimum spending required to receive an hour of free parking. Both P and S are prices perceived in a visitor's mind, so P, S together forms a dual pricing portfolio which differs from the unit pricing decisions for public parking. The mentioned previous study in 2014 detailed the monetary flows involved, set up the goals to increase the mall's total revenue, and formulated a goal programming model to decide the best dual pricing portfolio. However, it just performs some solid data mining processes for the computer data parameters. And questions remain as to how to accurately investigate other non-computer parameters for truly precise decision-making process using the decision model, as this is also stated by the authors in that study, since it is key to expect more profit in the market under crucial competitions. A critical building concept of the decision model is WTV, which stands for willingness to visit. It is a pro rata-based number that determines the degree to which a mall's driving visitor is willing to visit the mall, and it can be broken down into two parts influenced by two sorts of factors. A part affected by the parking pricing policy, and another part conditioned by all other factors. In other words, based on the decision maker's belief by reference to the studies in public parking, mathematically, WTV is a function of the dual pricing portfolio, which can be written as equation 1. Equation 1 defines W of P and S, and it has W prime PS component, which interprets the degree to which one's WTV is depressed by the portfolio using the 0 to 1 scale. It is a function of P and S further, as equation 2. In this study, it is focused on investigating the 5 parameters for equation 2, which are P bar, P underscore, S bar, and S underscore. In addition, there is Z, which means the bias in terms of a percentile value toward P against S, while a driving visitor is conceiving and forming the WTP part that is determined by C1. To assess this variable accurately and properly is critical for making a precise dual pricing decision, because what do matter are these parameters. Now see the right plan for W from PS. It is bounded by the P bar, P underscore, S bar, and S underscore. And Z determines the tilting degree of the sloping plane in the left figure for WPS. W prime PS determines its value because the term 1 minus A multiplied by B is a constant. Because WTV is important for making the decision for several reasons. A thorough and scientific investigation to understand the parameters of W of PS is important, but there just lacked a solid yet grounded basis to understand the accurate values for those parameters. There were problems for the values used for these parameters in the previous study. For example, no real driving visitor was interviewed for the upper and lower bound values of P and S, and for the value of Z, it is questionable due to the lack of sufficient samples and the way in which the survey was conducted. Therefore, this study presents a scientific method or flow to investigate those bounds on a solidified basis and the value of Z, which is a mental bias that is usually unforeseeable. Note that here we treat Z as a potential variable to be inferred and estimated, rather than polled using other direct devices, because this is a mind-mining process per se. We present the methods and results together to save time. A revealed preference questionnaire is designed at first. It contains 4 blocks of questions. Block 1 explains the purpose of the survey. Block 2 contains multi-choice questions to understand the basic profile of the respondents. Block 3 contains questions for polling the upper bounds and lower bounds of P and S. Block 4 randomly shows 10 reasonable combinations of P and S and asks for the WTV levels between 0 and 100, excluding all other factors, which is W prime. Then a thorough survey is conducted in the same shopping mall with a sufficient number of respondents. Eventually, the sample contains 72 respondents using the complete case study method. A sample questionnaire is shown here for reference. It contains Block 2 questions, Block 3 questions, and Block 4 questions. Then the answers collected from the effective respondents are registered in Excel files to form a data warehouse. Here we have some niche designs for Block 4 questions. For example, we ask 10 questions at a time to avoid overlooking, and the set of 10 different questions varies questionnaire by questionnaire. However, the number of meaningful samples is augmented by 10 times the number of respondents. Next, in order to have a regression model that fits the collected data tuples of W prime, P, and S, equation 2 is first derived as equation 4 after several trials by assuming that both P underscore and S underscore are 0. This is reasonable because by reference to the public parking literature, it has been evident that there is a strict price upper bound that deters almost all road users from driving, but no lower bound has been discussed. Then we transform equation 4 into equation 5 by assigning several symbolic definitions to the terms. Equation 5 estimates the extent to which a unit of price change in P or S may affect the WTP part of C1. In this study, we eventually have a regression model using the ordinary least square method, like equation 7. While we have the unbiased estimators gamma 1 star and gamma 2 star from the ARR model, we can construct a simultaneous equation system, or the SES, to infer Z using the mathematical relations in equation 6. Let P bar equals to S bar multiplies K. K star becomes another variable to be solved and estimated along with Z star. Introducing K allows a good mathematical property that two equations solving two variables and this provides additional information to be compared with the value of k calculated using the data directly. Apart from these, we believe that Z star is the most valuable knowledge because it represents the bias toward P against S in the driving visitor's mind while considering whether to visit a mall. It is a mental status while the WTV is formed. In this study, we used the average of S bar and the median of S bar over the entire sample for equation 6 and obtained two SES solutions. As a result, both solutions indicate that the true value of Z is around 0.8 rather than 0.6 that was assessed in a rough way previously, and such an estimation is inferred based on a large sample size of 720 using a method that is sound scientifically. Besides the investigation of Z for the main research question, some stratified analysis into the investigated lower and upper bounds of P and S may explore another set of knowledge about the consumer behaviors. And this can benefit other activities than dual pricing for management, such as relaunching the marketing plans. So let's begin with the table of the sample stratifications and show the median and mean of these bounds of people in these stratifications. Appendix B gives data spectrum analysis for these bounds. These are the sample stratifications in terms of gender, age, and membership type. And these are the mean and median values for those bounds for each sample stratification. We used blended histograms to visualize the analysis by sample stratifications. We present figures 3, 4, 5, and 6 here, and then make only some discussions related to P underscore across the figures for illustration. For the relevant discussions about P bar, S bar, and S underscore, please see the paper. This is figure 3 for the entire sample. This is figure 4 for the stratifications by gender, and this is figure 5 for the stratifications by age sections. For each subfigure, we have two subfigures to make things more clear. And also for figure 6, for the stratifications by membership grade. So for P underscore across these figures, first, many driving visitors believe that the lower bound of P should be 0 or 20. This is far lower than the current parking fee, which is 30 per hour. Females overall perceive a lower P than males. And older or younger people perceive a lower P than the two youth groups. But opinions of the 41 to 60 group are quite diversified. In terms of the member type, VIP members perceive a lower P underscore than normal driving visitors. And surprisingly, VVIP members perceive the lowest P underscore, which is $5 per hour. This is far lower than another two customer groups. Furthermore, in every membership group, the respondents' opinions are all diversified. Now let's go into the main insights gained in overall. First, in driving visitors' mind, P is 4 times important than S, instead of 3 to 2. This is for the mall managers to understand and manage the consumer psychology and behaviors. In the literature, there are other consumer behavior topics studied for malls, but they rarely touched this topic. This means that such knowledge is novel for the mall managers. Second, through this study, we understand that P and S are different concepts, and failing to assess these bounds of P and S accurately simply leads to poor dual pricing decisions. Third, females perceive higher durable upper bounds for both P and S. Together with other findings for the female group, the managers may launch differentiated marketing strategies for female visitors. Fourth, the senior visitors group becomes another spot to promote some marketing strategies about parking, since it is a growing market segment. And then the VVIP customers may form another special segment for marketing. Fifth, the perceived upper bound of S always increases with the upgrade in membership level. This becomes another worthy topic for future exploration. Lastly, there will always be a group of people who think that, at best, parking should be free or being offered at a very low cost. Although this is also a sign for the mall managers, considering the fact that people in East Asia usually give face to the investigators, so the lower bound values may be answered overly. This insight reflects to the fact that studies addressing the lower bound topics of parking pricing are scant in the literature so far. Anyhow, the contribution of this study are on the exploration of the empirical knowledge and the methodology. We propose a systematic flow to investigate the knowledge about Z, which is a psychological matter pertaining to mall driving visitors' perception and attitude. And the flow links and hybridizes several well-known methods. This flow can be summarized as a figure. Such a process has certain novelty, but for the required mind-mining process, it is nothing hard and easy to implement. Then, for empirical knowledge, accurate and credible parameters are investigated for the decision model to make a precise decision for P and S. For this matter, we recall that precise and smart decision-making is always necessary in the era of data-driven decision-making. Findings during the stratified analysis about the upper bound and lower bounds of P and S also solidify those deepened insights gained. These are for the mall to promote some market segmentation-based dual pricing portfolios for some visitor groups. In the future, for the mall, it can improve itself according to the recommendations. And for us, there are future research directions. For example, the proposed flow may also be applied more generally to fit the research purposes of other domains facing with a similar mind-mining problem. This is my presentation today. I am Wen Zhengyun Zhuang from National Kaohsiung University of Science and Technology. Thank you. It's time for Q&A.